Today we're going to be talking about patterns in arithmetic and geometric sequences. Review of Algebra 1 and Algebra 2 because you guys have done this before. Okay? We're going to take it up a little bit of a notch and incorporate some IB language, some IB vocabulary in here with it. Okay? So, you guys are going to be able to use the formulas to find different parts of an arithmetic sequence, and then depending on how much time we have left, we probably will continue on into geometric. Okay? So, let's start off with patterns though. All right, remember, smart notes. Smart notes. Okay? A number sequence is a pattern of numbers arranged in a particular order according to a rule. That's what a sequence is. It's a pattern of numbers that are arranged that go towards some type of a rule. And each individual element within that sequence, bless you, is called a term. Okay? For each individual number or element of that sequence is called a term. So for example, if you look at that very first example that's in the black, 14 would be considered the third term. Okay, if you look at the last one, 25 would be considered the fifth term. Okay? Being able to recognize patterns is good because it kind of helps out with determining whether or not something is arithmetic or geometric when we get to it. So, if you look at the first example, you have 8, 11, 14, 17. You know the pattern? Bodie, what is it? Plus 3. I'm adding 3 each time. So if I wanted you to find the fifth term, you would tell me what? It would be 20. So the pattern is plus 3. Fifth term would be 20. Okay? Trying to see if you guys are able to recognize patterns. Okay? When I look at the next one, we have 800, 400, 200, 100. Recognize the pattern? Zach, what is it? I'm dividing by 2. So then what would be my fifth term? It would be 50. I could divide by 2, or I could what? Multiply by 1/2. Very good. All right. This next one, I have 1, 4, 9, 16, 25. Recognize the pattern? Sarah. They are the perfect squares. They are the perfect squares. So my next one will be what? 36. Yes, the next one will be 36. So if they're the perfect squares, how could I potentially write that? I could write out perfect squares. What's another way I could write this? N squared. And what would n represent? The term. The first term, 1 squared is 1. The second term, 2 squared, 4. The fifth term, 5 squared, 25. Very good. And the last one, I got 5, 10, 15, 20, 25. I'm adding 5. So the next one will be what? 30. Recognize the patterns. We're good? Okay. Let's get some real stuff. All right, arithmetic sequence. Okay? Terms that increase or decrease by a constant value called the common difference. That terminology has not changed. It is still the same as it was back in Algebra 2. The common difference is denoted by the variable d. And there's the formula for you there. That 1 is supposed to be a subscript. It's not side by side with the u. Okay? So, u sub n equals u sub 1 plus n minus 1 times d, where u sub n is the nth term. So, n represents your number of terms. So, if you were looking for the fifth term, n would be 5, u sub 5 would be the fifth term. U sub 1 is the first term, and d represents your common difference. Okay? The formula is in your reference booklet under topic 1, so you don't have to worry about memorizing it. You just need to know how to use it. This legend, I guess, is not given to you. Okay? You need to know what each of the variables and everything represent. All right? Let's look at an example. So I need to find the 12th term of the arithmetic sequence 13, 19, 25, dot, dot, dot. The ellipses mean to go on forever. Find expression for the nth term after we do that. So, you always want to see if you can recognize whether or not this is arithmetic or not. 13, 19, 25. Does it increase or decrease by a constant value? What is that constant value? 6. Am I adding or subtracting it? You're adding it, so it's a positive 6. So because it does do that, it is arithmetic, we're looking for the 12th term, which means that 12 is going to be what in our formula? Just the 12. The 12. The 12 is the n. So it's going to be u sub 12. Then I need u sub 1. What is my first term? 13 plus n minus 1. Well, n is 12 minus 1 times my common difference, which is 6. Okay, that u sub 12 is technically what you're looking for. At this point, we're just doing the operation. Now, there's no need for a calculator on this one. I'll let you know which ones need a calculator. Okay? What is 12 minus 1? What's 11 times 6? So we basically have 13 plus 66, which is 79. Don't be afraid to show your work. You never know where those method points may be coming from. Now, B asks you to find an expression for the nth term. The nth term. If it's asking for that, that means we're not plugging anything in for n. Or we plug in everything else. Okay? So I'm looking for the nth term, which is u sub n. What's my first term? 13. Plus n minus 1, because again, I'm looking for the nth term, which means I don't have a value for n. But I do have my common difference, which is what? 6. You never want to leave your expression this way. It can be simplified some more. How can I simplify this? Distribute the 6. So I have 13 plus 6n minus 6. Can anyone tell the difference between my 6's and my b's? That's clearly a 6, right? Okay, my b's, they look like this. My 6's look like this, okay? Know the difference? However, if you ever have a question, just let me know. I'll let you know if it's a 6 or a B. What can I do from here? Combine by doing 13 minus 6, which is what? 7. So 6n minus 7, that is my expression for the nth term. Bless you. Which means if I wanted to, I could ask you what's the 201st term of this sequence. You have a nice simplified formula or expression that all you have to do is plug in 201, and you have your 201st. Question? Because I made the mistake that should definitely be a positive. Is that what you're going to ask? Thank you. I am human. It does happen. Got a little excited. In your head. Good? All right. Let's take a look at this one. Let's find the number of terms in the arithmetic sequence. 84, 81, 78, dot, 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 12. I'm looking for my number of terms here, okay? All I know is that I have 84, 81, 78, and then dot, dot, dot in the middle, and then 12. That dot, dot, dot means I have a certain number of other terms that are within this. Now, yes, you could sit there and you could recognize that, hey, the common difference is what here? -3. So you can sit there and you can subtract 3 as many times as necessary to get down to option to 12, okay? Heaven forbid you lose count or you second guess yourself. Is it really 32 or is it 33? You know what I'm saying? Okay? That should be a last minute resort. Okay? Like you have 1 minute and you have been stuck on this problem the entire test and you're like, okay, we'll bump it. Let's subtract. Let's subtract. Okay? How do you find it using the formula? Well, remember, this is the formula to find the nth term of a sequence. Well, don't I already know what the nth term is? 12. So I can replace u sub n with 12 because that is the nth term. What's my first term? 84. The one thing I don't know is my number of terms. Is what I'm looking for. So I'm looking for n. What's the common difference again? -3. And now I have a nice little linear equation that I just need to solve. Okay? Now I'm curious. I want you guys to solve this linear equation. I want to see the different ways that you guys solve these problems. Okay? No calculator. No calculator. Now n represents like a particular term in the sequence, which means it always has to be two things. It always has to be a whole number, because you don't have like a 15.5 th term, right? And it can't be negative, because there's no such thing as a negative second term. Okay? So n has to be positive and a whole number. Did you guys get a positive whole number? Okay. Now it's interesting to see how you guys solve this. I always want to see if there's any students who do it like reverse order of operations and not distribute. Okay? Majority of you guys distribute, but some of you guys actually did it where you subtracted 84, divided by -3, and then added 1. Okay? That's the way I do it. So I'm going to subtract 84. Okay? Because to me, I don't know, I like it a little bit better. I mean, let's look at the same answer whether you distribute and then do it that way. Raise your hand if you did this way. Okay? 12 minus 84 is what? -72. And that's because I think I'm really good with like my times tables and stuff, so division is a little bit easier for me. When I divide by -3, a negative divided by a negative is a what? Positive. So when I divide -72 by -3, that should give me 24. And then 24? Okay. And then add 1. So you guys got 25? So that means that you would have had to subtract 22 times before you got to 12, if you did it that way. Don't do it that way. Questions? Y'all remember this? Awesome. Take it up a notch. Get this one. Okay. This one is arithmetic sequence. U sub 9 is 48 and U sub 12 is 75. We need to find the first term and the common difference. But I don't have two neighboring terms beside each other to do this. Suggestion. Okay, so we can use the 9th term as our first term just temporarily, and then use our 12th term as our third term, and then find the difference using the formula, I'm guessing, right? You ever hear that? Okay, so going to use my 9th term as my first term, so I'm going to temporarily put 48 here. And then I'm going to make my 12th term my third term. So then that means I'm going to plug in 3 in here. Okay? You sure it's my third term? Is it, or is it first? It's fourth, okay? And this is one of the things, like when we temporarily make it, so you got to be very careful about that, okay? So it's going to be my 4th term. And I'm looking for my common difference. What do I put here for U sub n? 75. Okay? 4 minus 1 is 3, so I'm going to subtract 48 from both sides. 3d equals 27. And d equals common difference, I can find my first term, right? Go back to normal. Use one of my terms and the formula to find my first term. Which term do you want to use? Plug in 9. So that means I'm going to use 48 here. What's 8 times 9? Subtract 72. What's 48 minus 72? Yes? I need your calculator. Quick. Questions? Done these problems before, okay? Done these problems before. Let me show you a shortcut on this one over here, okay? When you said like make whatever your first term, I was kind of like, oh geez. Okay, yes, you can do this. You can do this, but there's a shortcut to doing this, okay? Take your terms, okay? You can do 75 minus 48, or you can do 48 minus 75, but it doesn't matter. Subtract your two terms, okay? Then divide them by where they're placed in the sequence, okay? So 75 minus 48, 27, 12 minus 9. You get the same answer, okay? And essentially that's what you're doing here, but also prevents the possibility of you using the wrong n. You know what I'm saying? Just another way. Questions? I want you to try this IB example on your own. If you want to write down the question, you can. You don't have to, but I do want you to do it, and I'm going to give you 5 minutes. All right, so Chris, what you get for A? 302? 302? Yes, it is 302. So all we do is we just, this right here, this notation basically is asking for the what? The 101st term. Okay, so you're plugging in 101 for N, 2 for U1, and solving it out. And for B, it's asking you to find the value of N, aka the what, Vegas? What's N represent?
Number of terms.
I'm looking for the number of terms, and I have the use of N term, which is 152. And Vegas, what you get? 51? Very good. 152 equals your first term plus N minus 1 times the common difference. What was the common difference? 3. Very good. And so, yes, N equals 51. Good? Guessing easy, right? Okay. Good stuff. All right. Well, let's talk about geometric. That's all I want to say. Before we move to geometric, real quick, because this was one of the questions that was in the example, so I just want to make sure that you guys are aware. In IB, they like to do problems that say show that. Okay? Show that blah, 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 blah. These show that problems are basically looking for the work that's associated with whatever it is it's asking you to show. In other words, they're going to give you the answer. You have to basically go through and show the work of how to get to that answer. Okay? So for example, let's say there was like a part C in this problem, or maybe even like something before this last question. And it said to show that the common difference, and I'll merge that together, but y'all get my point. Common difference is 3. Okay? They probably have a few extra words in there, like show that the common difference, comma D is 3, something like that. Okay? To show that, you really need to legitimately show the work, even as simple as it may be, you would need to show that. How would you show that the common difference is 3? 5 minus 2 equals 3. 8 minus 5 equals 3. 11 minus 8 equals 3. If you're like, Miss Anderson, but like you've already kind of gotten to your point, but you haven't showed it to the point that IB wants you to show it. If they give you 4 terms, you need to show that it works for every single one they give you. That makes sense? And this is how you would show that the common difference is 3. This is not acceptable. Because in this example, you're using the answer they gave you to verify that yes, 3 is the answer. But the work over here is actually showing that the answer is 3. Y'all see the difference? Okay? So be careful on those show problems, all right? And as we go through the content and everything like that, I'll try to bring up other examples of where you have to show, and you want to be careful on how you actually show it. Okay? Well, let's talk about geometry. Geometric sequence, very similar to arithmetic. It has its own set formula. But this is when each term can be found by multiplying the previous term by a constant value. This time it is R. This time it's R, same for common ratio. Okay? So there's a difference. It says find B, you know you're dealing with arithmetic. Find R, you're dealing with geometry. Your formula, u sub n equals u sub 1 times R to the n minus 1. For R is your common ratio, n, u sub 1, and u sub n are still the same. Okay? All right. Okay? We want to find the 9th term of the sequence. And we want to find the 12th term of the sequence. Okay? You're using that formula. U sub n equals u sub 1 times R to the n minus 1. You'll need your calculator for both of these. And I want you guys to do these on your own using the formula. See if you can, you have that skill. Use the formula to find your 9th term and your 12th term. And as tempting as it may be, show some work. So, find the 9th term. You need the common ratio for number 1. And now what you get for the common ratio for number 1? 4. Yes? Yes? Okay. So 4 raised to the 9 minus 1. So basically you're doing 4 to the 8th power. Yes, this would be a calculator problem. I would expect you to know 4 to the 8th power. But I would expect you to know 4 to the 6th power. That's fair game to be not calculated. Okay? Yes? Understand? 4 to the 6th power? Good stuff. So what was your answer? Read out the numbers. 6 by 5? 3, 6. Very good. Okay, so that's your 9th term. All right, and then over here, find the 12th term in the sequence. I need a common ratio. John, what's my common ratio? -2? What's that? Yeah, okay. -2, I'm going to raise that to the 12 minus 1. Okay? Now, do you still have this on your calculator? Like the typing in of this one? Cleared it out? Okay. All right. Well, real quick. Okay? Did you have it? Okay. Never mind. It's like look at my thing that froze on me. When you typed in, did you include the parentheses? Or did you just do times -2 to the whatever power? No parentheses? Huh? You did it separate. That's a good way to avoid any issue. Anybody was big and bad, did it all in one line? No? We all did it separate? Okay. Well, that's good. Then we don't have to worry about this. But I am going to say this anyway. Everybody knows that a negative number raised to an even power is a positive number, correct? Even if you do it individually, you have to be careful. Because, again, the calculator reads order of operations. And I wish I could show you, but I think my thing is starting to freeze, which it does often. If you type in this, everyone type this in. -2 to the 10th power. You got a negative number, didn't you? Okay? You have to be careful. What the calculator reads when it does this is it's saying take 2, raise it to the 10th power, then make it negative. Okay? So you want to be careful. If you want the calculator to give you -2 to the 10th power, you have to do it with parentheses. Okay? It didn't affect you on this one because it was an odd number, so it's still going to be negative. But But on an even one, this is how IB will get you. Okay? So that's going to be 2 to the 11th power. And what was that as an answer? -2, 4, 0, 4, 8. Like that. For me, it works a lot better just read out the numbers from left to right. So give me 2048 because I'll for whatever reason it doesn't process that well. Okay? Good? Okay. Step it up a notch a little bit. Just tap it. Okay? This one. In a geometric sequence, we have two terms, one of them being the first term, and another one being the fourth term, causing us to have to find our common ratio. This one's non-calculator. Non-calculator. Okay? Now, you might be able to see what the common ratio is off gate. I can't. I mean, actually, I can't because I've done this problem the same for like the last 7 years. But, you know, still use the formula to help you out some. Okay? U sub n, U sub 1, r to the n minus 1. I have my first term, which is great. I'm going to plug that in. 864. I don't know what r is. But I do know that my fourth term is 256. So what does that mean? What can I plug in for n? 4. And then what can I plug in for u sub n? 256. Now this is non-calculator because you basically are doing a little bit of simplifying of fractions. And this is to the third power, which means that when I solve for r, I'm going to need to get rid of that third power. So how do I solve for r? What do I need to do first? Divide by 864. I need to reduce this fraction right here. Okay? Reduce that fraction. Non-calculator. Reduce it. What you get? 2 over 7? What you get? Ooh, man, look at me. I might have hit a speed bump somewhere amongst those divisions. Not 2 over 7. Wait, you're talking about like, I'm talking about just the reducing. Yeah. No, not 2 over 7. 8 over 27? 8 over 27. So it'll be 8 over 27 equals r to the third power. How do I get rid of that third power? How do I get r by itself? Take the cube root. Don't forget about those skills of getting rid of exponents. You take the cube root, square root, fourth root, whatever root is asking you for, and both of these are perfect cubes. What's cube root of 8? What's cube root of 27? So r is 2/3. Yes? We good? All right. Two more problems. This one is calculator. The last one is non-calculator. Step it up again. For the geometric sequence 5, 15, 45, we're going to find the least value of n such that the nth term is greater than 50,000. But that's IB wording for you. Find the least value of n such that the nth term is greater than 5,000. So what am I looking for here? And don't just reread, like in layman's terms, like if you got this problem, what do you think it means to you? Huh? So we're finding n when the u sub n term is bigger than 50,000. That's basically what it is. So we're looking for n, and more specifically, it has to be that term that takes me above 50,000. Okay? Now, it is calculated, so if you wanted to, you could figure out what the common ratio is and sit there and multiply by the common ratio until you get to that term that is greater than 50,000. But that might be a while of multiplying by what? What's the common ratio? 3. Okay? And plus, I don't know how many points you actually get for that in IB world. So, let's actually set up the formula and let's do this. We're looking for when the u sub n term, which is u1 r to the n minus 1, is greater than 50,000. That's essentially what we're trying to do. We're trying to find. What's u sub 1? A little louder because I can't hear you over there. It's what? Are you sure? What is it? Oh, wow. I think u sub 1. I'm sorry. Yes, u sub 1 is 5. I apologize. Let's still should have been louder. What's r? 3. Sorry, I thought I asked what is r. Y'all kept giving me 5. I'm like, no, it's not 5. It's 3. Then I realized what I said. So I apologize. And just in case if you're unsure what the common ratio is, you can always find your common ratio by taking your second term and dividing it by your first term. Or you can take your third term and divide it by your second term. This is also how you would show that the sequence is geometric. That's also how you could show that the common ratio is 3. Okay? By the actual dividing out of the terms. Okay? All right. So, how do I solve this? Divide by 5. So I get 3 to the n minus 1 is greater than 10,000. Now I got an n in the exponent, my variable in the exponent. I still got this inequality. What do? Log. Does everybody remember how to do logs? Yes? Maybe? Okay? No, not so much. Well, how about this? I spent some time with some calculator 101 with you, right? And it is a calculator problem. Let's use our calculator to solve it, okay? Logs can also solve this problem, but let me show you how to do it in your calculator, okay? Now, what I'm about to write is for you only. Never write this on your test, okay? What we're going to do is we're going to type this side of the inequality into y1 and this side the inequality into y2. But don't ever write that. I just do this so you guys know that this is exactly what we're about to do, okay? So let's go into our calculator. We're going to graph this. That's right. Forgot this thing is not working. Okay? So 3 raised to the x minus 1. Yes? Okay? And then 10,000. Yes? All right. Now, if I were to click graph right now, do you remember what the window was for our graph before? It only went up to 10. I'm trying to graph y equals 10,000. 10,000 is not going to show up on the window that I have right now. So I need to adjust my window. How do you do that? There's a button that says window. You click it. It's right beside your y equals. And yours should say negative 10 to 10, negative 10 to 10 because we reset it. Remember, I had to force restart this, so this is what the old setting was. Don't worry about this. Okay? I'm going to take this back to negative 10. I'm going to take this to 10 because that's where yours is. Always leave your scale as 1. Okay? X scale represents the scale you want to go by your 1. We can leave this as negative 10, but again, I'm graphing y equals 10,000. I probably want to see 10,000, correct? Okay? So I'm going to change this to 10,000. I don't have to press clear. I don't have to press delete. I just start typing. It basically overwrites it. Okay? So now when I go to graph, it's adjusted the window. The blue function was the 3 to the x minus 1, and there's the 10,000. Does everybody's window look like this? Okay. And I'm looking for that solution, where those two lines intersect. I showed you how to do that, right? How do I go there? How do I get that intersection point? What do I do? Second trace. Which option? 5. And now what do I need to do? I need to move it closer. Now, granted, an exponential function and a line are only going to cross at one point, but to harp on, you want to be closer to the intersection point, I'm just going to move it closer. Now, if I try to move it one more over, it's going to take me out of my window, and I don't want to do that, so I'm going to leave it right there. It's close enough. And then what do I do? How many times? So 1, 2, 3, and x, aka n, is what to 3 significant figures? 9.38. So n is about 9.38. But can n be a fraction, a decimal? It has to be a whole number. So what is the least value of n such that the nth term is greater than 50,000? 10. So n equals 10. Always provide the non-rounded answer before you provide the whole number answer. Okay? Use an IB problem, use your calculator. How do you feel? Nothing. Nothing excites you all. Okay. All right. Questions? Laws will also get you to this point, but I'll save that for when we actually go over exponential and logarithmic functions. And plus, you need to practice doing it. And it works every time. Let me show you something else, too, while we're on the problem. Everybody press second graph. The second graph option takes you to a table. And the table basically gives you all the x values and the corresponding y values that go with the two functions. Now, we could have used the table to see exactly where the function is going to be greater than 10,000 right here to get our answer of 10. The only issue is that I've done enough mark schemes, I've seen enough mark schemes to know that doing this will not suffice. They want to see that non-rounded answer. They want to see that 9.38 before they actually see the 10. Okay? So use the intersect feature to get your answer, and if you want to confirm, you can use the table. Make sense? Okay. All right, what am I looking like on time? Still got 10 minutes. Okay. One more, and then we'll be done for the day. I want you guys to try this one on your own. Let's see if anybody gets the gold star for today. Okay. Yes, you want to use that. You want to use the fact that the second term divided by the first term gives you your common ratio. What else gives you your common ratio? Besides doing second divided by first. And no matter what, shouldn't they be the same? So you set them equal to each other. 4x plus 4 over 7x minus 2 is equal to 3x over 4x plus 4. Because these will give you your common ratio, so they should be equal to each other. Okay? So you set them equal to each other. How do I solve this? What do I need to do? Cross multiply. So that's going to be 4x plus 4 times 4x plus 4 equals 3x times 7x minus 2. Again, we set up that equation from the top line, because the second term divided by the first equals the third term divided by the second, and they should be the same because it represents your common ratio. Cross multiply, and now what I'm going to need to do to the left side? Distribute, FOIL, and then same thing with the right side. So that's going to give me 16x squared. What's 4x times 4? So I have a 16x plus a 16x. What is that? 32x plus 16. What about on the right side? What's 3x times 7x? And what's 3x times negative 2? And this right here is a good old what? Huh? That hurt on the side, like these fingers. It's a parabola. What's the name for the parabola? It's a good old quadratic. How do you solve a quadratic equation? Quadratic formula or factoring. Factoring because quadratic formula is a lot. All right. In order to solve a quadratic, everything basically needs to be equal to what? 0. So I'm going to subtract over the 16x squared, subtract over the 32x, and I'm going to subtract over the 16. So that's going to give me a 5x squared minus 38x minus 16. Bless you. Now I gotta take it back because I don't know how many of y'all remember how to factor. Huh? So, her someone say family.
Well, if you multiply 5 by 16, then you get that and you find the factors from the
You slide divide bottoms up. I don't know if you're sorry, my students know this is slide divide bottoms up. I don't know about the rest of y'all, okay? But yes, you need to multiply the 5 times the negative 16. That's the slide part. What's 5 times negative 16 without your calculator? That goes on top. What goes here? And you're looking for two numbers that multiply to give you negative 80, but add together give you negative 38. Negative 40 and positive 2. Okay? You guys did this last year. Should have done it last year. I don't know who your teachers were. So that's the slide part. Now you have to divide and bottoms up. At least that's how I taught it. Did you teach this stuff? What am I dividing? By 5. What's 40 divided by 5? So I have x minus 8. Can I divide 2 and 5? So I have to what? Bottoms up, bottoms up. There we go. And all this is equal to 0, which you can solve at this point. Which one's the positive value?
8.
So x equals 8. The other one is negative 2/5, so they ask for the positive value of x. And a good overview of geometric and arithmetic sequences. Okay? IB arithmetic and geometric sequences. Do you notice the difference between algebra 2 and IB? Okay. So your homework is more IB. Okay?